Hello everyone and welcome to UK Foundations. I'm Uthara Adithi and today we'll be solving acid bases and salts chapter MCQ questions. So let's begin without any further ado and let's try to complete this MCQ questions as quick as possible. Okay, so the first question says that what happens when a solution of an acid is mixed with a solution of a base in a test tube? So you know that acid plus base is a neutralization reaction which is exothermic, right? So neutralization reactions always lead to the formation of a salt. So of course this is correct. The temperature of the solution remains the same. Does it decrease or does it increase? Because this reaction is exothermic in nature, temperature should be evolved and the temperature of the solution should increase. So according to that it should be increases. 1 and 4 are correct. Okay. Next, moving to the next question. An aqueous solution turns red litmus to blue. Excess addition of which of the following would reverse the change? So red is becoming blue, so you know that the solution must be something basic. If you want to get the reverse from blue to red, then it should be an acid, right? If you have an acid or an acidic condition, it will become red. Talking about which of these being acidic: baking powder, lime, sodium hydroxide, HCl. HCl, of course, here itself it's given as acid if you don't know, but there's no chances that you won't be knowing it. So HCl is the answer, right? Moving to the third question. During the preparation of HCl gas on a humid day, the gas is usually passed through a guard containing calcium chloride. The role of calcium chloride taken in the guard is 2. So this is an activity in the Ncert textbook being mentioned. So the role of that calcium carbonate in one of those activities is basically, what is the setup? The setup is to show that the litmus paper changes its color only when it reacts only to the ions, whether it's H plus or OH minus ions, and it is not to an acid like HCl or to a base like NaOH, right? It should be in an aqueous solution for the litmus paper to respond. Okay, so the role of calcium chloride here is to absorb all the moisture, okay, and to make sure that there is no moisture in the test tube or in the setup. Okay, so it's third option, absorbs moisture from the gas. Next, which of the following salts does not contain water of crystallization? Blue vitriol, you know that it's CSO4 blue vitriol is copper sulfate, right? It has its water of crystallization. Baking soda, yes it does. Wait, just a minute, give me a minute. Blue vitriol is copper sulfate and it has its water of crystallization. Baking soda is NaHCO3. Okay. Washing soda is Na2CO3.10H2. It has its water of crystallization, likely gypsum too. So which does not contain water of crystallization? It's B. Right? Water of crystallization is basically the fixed amount of water molecules present in the crystal, right? So it's absent over here. So that's the answer. Next. Okay. Sodium carbonate is a basic salt because, see, even though if you suppose by any chance you don't know sodium carbonate is basic, then also it's given in the question that it's basic salt. How do you show that nature? If it's made up of a strong base being dominating, then only the overall solution can become basic. So here and here you can see the strong base, but should the acid be equally strong or should it be weak? If it's equally strong, right, it's hard to decide which one's acid will the outcome be, acidic or basic, and mostly it'll be neutral. So it should be a weak acid to say surely that it's a basic salt. Calcium phosphate is present in the tooth enamel. Okay, so calcium phosphate is present in the tooth enamel. Now we have to tell its nature. Calcium phosphate, if you see, it's made up of calcium hydroxide and the phosphate, right? This will be the case. Okay, so if you see, calcium hydroxide is basic, this phosphoric acid is very weak acid. It's a weak acid, so the answer, it's basic in nature. Okay, the phosphate ion will result in formation of a weak acid, so obviously the overall solution will be basic in nature. Okay. Oops. Yeah. A sample of soil is mixed with water and allowed to settle. The clear supernatant solution turns this pH paper yellowish orange. Which of the following would change the color of this pH paper to greenish blue? Okay, so first let's just analyze the options. Are they acidic or are they basic? Okay, lemon juice is of course acidic, vinegar is acidic, weak acid, but yeah, NaCl is neutral, antacid is base. Okay, so now greenish blue is kind of in the range of a base. Okay, if you note the pH paper, so it should be an antacid which is basic in nature and making it greenish blue. Okay, which of the following gives the correct increasing order of acidic strength? Of course, if you see, it's just a set of three same compounds being shuffled between themselves. So HCl should be the highest. I hope this is known. HCl, and acetic acid is CH3COOH, and water is H2. Water is neutral. Okay, and this acetic acid is a weak acid, HCl is a strong acid. So HCl should be in the first place, followed by acetic acid, then finally water. So the answer is first option. Okay, if a few drops of a concentrated acid accidentally spills over the hand of a student, what should be done? Okay, wash the hand with a saline solution. Saline is basically neutral. It's salty, right? Salty solution, saline. Wash the hand immediately with plenty of water and apply a paste of sodium hydrogen carbonate. After washing with plenty of water, you should apply sodium hydroxide on your hand and neutralize the acid with a strong alkali. Strong alkali in the sense you can assume it to be NaOH or KOH or anything as such. Now let's see what can be done. If you put sodium hydroxide, you might be thinking concentrated acid, so it's very much acidic. So we have to put equally, a strong base to neutralize the effect. But if you put sodium hydroxide, it's equally corrosive. It can harm you just like the acid. So of course these two will not come. And also you can eliminate the option by seeing that strong alkali will include even sodium hydroxide. If suppose one of these are the answers, then both of them will become correct, right? But two options are not possible to be right at the same time. You should apply sodium hydrogen carbonate, which is a mild base and can serve the purpose. Okay, sodium hydrogen carbonate when added to acetic acid. Sodium hydrogen carbonate when added to acetic acid evolves a gas. Which of the following statements are true about the gas evolved? Okay, so sodium NaHCO3 along with acetic acid. Okay, this will yield you CH3COONA, then water and CO2. CO2 is being evolved. So the test for CO2 is of course the lime water turning milky. So this is correct. It extinguishes a burning splinter. Okay, does it extinguish a burning splinter? Then it dissolves in a solution of sodium hydroxide, and finally it has a pungent odor. Of course it doesn't has a pungent odor because CO2 is around us and we don't find any pungent odor around us. So fourth option being eliminated, these are also eliminated. One must be there. And speaking about the third one, it dissolves in a solution of sodium hydroxide. Nothing such is being observed. So it's 1 and 2. 10th one is first option. Okay. Yeah. Next, 11th question. Common salt, besides being used in kitchen, also is used as a component for the formation of other raw materials. So we have to find out what they could be possibly, right? So washing soda, yes. Bleaching powder, yes. Baking soda is indirect use. You can't tell directly you're obtaining it. And slate lime, of course not. So it's 1 and 2. It's directly from the textbook part. Okay. One of the constituent of baking powder is sodium hydrogen carbonate. The other constituent is baking powder, right, is sodium hydrogen carbonate. Just a minute. Is sodium hydrogen carbonate. Then the other constituent will be, we know that a mild acid is being added. Yeah, right. A mild edible acid along with sodium hydrogen carbonate. So henceforth it's tartaric acid. Okay. Next. To protect tooth decay, we are advised to brush our teeth regularly. The nature of the toothpaste commonly being used will be which type? Yes, it is basic, because in our teeth, the acids, after you eat the food, the acids are being acted upon, and there are bacteria. To kill that bacteria and to neutralize the effect of acid, a base needs to be added. Okay. Next. Which of the following statements is correct about an aqueous solution of an acid and of a base? Higher the pH, stronger is the acid. What happens? 0 to 7, 7 to 14, right? 0 to 7 you can see acidic nature. 7 to 14 it's basic. Okay, so higher the pH, stronger is the acid or stronger is the base? First one is wrong. Okay, it can't be possibly the first option. Just remove these two. Okay, higher the pH, weaker is the acid. Yes, because it's becoming more of basic. Lower is the pH, stronger is the base. Lower is the pH, stronger is the acid. It's not the base. So it should obviously be the fourth option, which is 2 and 4. Okay, next. The pH of gastric juices released during digestion is gastric juices, of course, like it'll have pH of about like 1.2 to 1.8 around. Okay, it's very acidic and it is of course less than 7. Okay, yeah. Next, which of the following phenomena occur when a small amount of acid is added to water? When you're adding small amount of acid to water, what happens? Do you find neutralization? Neutralization will be done between acids and bases, right? Here you're just adding acid to water, so you don't observe neutralization. Salt formation, again, if it's neutralization, then you can tell salt formation. Ionization, yes, like the acid dissociates and forms the respective ions, and dilution, it is getting diluted. So it'll be 1 and 3B. Okay. Yeah. So, which of the following can be used as an acid base indicator by a visually impaired student? So, a visually impaired student, olfactory indicators to be used. Vanilla essence, onion or clove oil can serve the purpose. So, you can use any of these three, right? These are called as what? Olfactory indicators, right? Okay, so now, which of the following substance will not give carbon dioxide on treatment with a dilute acid? Okay, is it marble, is it limestone, is it baking soda, or is it lime? So speaking about this, if you see the first three options, they'll have carbonates. So you'll be able to see carbonates, right? So these three will yield carbon dioxide. While talking about lime, lime is calcium hydroxide, right? Calcium hydroxide reacting with an acid will not yield carbon dioxide, so it's fourth option. Okay, just about the formulas to be done. Next, which of the following is acidic in nature? Which of these are acidic in nature? Is it lime juice? Is it human blood? Is it lime water? Or is it antacid? Antacid, of course, it's not. Lime, you know the reason, right? Because it's used to neutralize the acid, so it must be a base. Human blood is not acidic. Okay, it's towards the neutral side and more of towards the base. Lime water and lime juice. Lime juice is basically made up of citric acid. Citric acid, lime and all of them made up of citric acid. So the juice is also made up of citric acid, making it acidic in nature. Okay, yeah. So now 20th one. In an attempt to demonstrate electrical conductivity through an electrolyte, the following apparatus was set up. Which among the following statements is or are correct? Bulb will not glow because electrolyte is not acidic. So let's just observe this. Electrolyte is our dilute NaOH, right? This is a direct experiment. NaOH. So will the bulb not glow? First of all, what happens here is dilute NaOH. NaOH is going to dissociate, right? It's going to form its respective ions, and because of these ions, electricity will be conducted. So So it will not glow is wrong, of course. Anywhere which will not glow is wrong. Bulb will glow because any which is a strong base and furnishes ions for conduction is correct. Only 2 is correct. Right? Yeah. Okay, moving on. I know I'm a little faster because this topic is easy and I just want to get it done as quick as possible. Which of the following is used for dissolution of gold? Dissolution of gold, that aqua regia is used, right? You'll have that 1:3 proportion of concentrated nitric acid and sulfuric acid being not sulfuric. You'll have HCl and nitric acid being taken in the respective proportions, and you can dissolve gold. And also platinum to be remembered. Okay, which of the following is not a mineral acid? Not a mineral acid. Talking about that, you will have, is it HCl, is it citric acid, is it sulfuric or nitric? Citric acid, if you know the concept of mineral acids, these are organic acids basically. These are organic acids. So it is not a mineral acid. Which among the following is not a base? Talking about which of them not being bases, NaOH is base, KOH is base, NH4OH is a weak base. These two are strong bases. This is a weak base. Okay, fourth option is C2H5OH, which is ethanol. Ethanol or ethyl alcohol. And this is not a base. So it's fourth option. Which of the following statements is not correct? Okay. All metal carbonates react with acids to give a salt, water and carbon dioxide. All metal oxides react with water, metal oxides to give an acid and a salt. Some metals react with acids. Some metals react with acids to give salt and hydrogen. Some non-metal oxides react with water to form an acid. So seeing all of them, if you know the concept properly, it will immediately strike that metal oxides in the second option, if you see, metal oxides are basic. Okay, so when you react it with water, it should yield something basic, right? There is no acid involved here. Water is neutral. This is neutral. Wait. Water is neutral, and the metal oxide, right, being basic, should finally yield a basic solution and not an acidic solution. So it is B. B is not correct. Okay. Next. Okay. Match the chemical substances given in column A with the appropriate application given in column B. So let's just see what are the possible options for A. Is it 2 or 3? Okay, is it 2 or is it 3? Does bleaching powder help in the production of H2 and Cl2, or does it help in decolorization? So it helps in, actually H2 and Cl2 is being produced by NaCl. Okay, so A should be 3, it should be B, or it should be C. Next, talking about B, it has a demand over 2 or 4. A baking soda, is it used in this part or is it an antacid? We know that baking soda is an antacid, so it should be 4. Okay, obviously this. Let's just check the rest of them. C being 1 or 4. Washing soda, is it used in the preparation of glass or as an antacid? Of course, you don't eat washing soda to get relieved from any pain, so it should be first option. And sodium chloride is B. Henceforth, third option is correct. Equal volumes of hydrochloric acid and sodium hydroxide solutions of some same concentration are mixed, and the pH of the resulting solution is checked by a pH paper. So what would be the color obtained? Actually, when you take equal volumes of a strong acid and a strong base, it will yield a neutral solution. Okay, so your color should range around 7, like around here. This range only should be there. Let's just see, is it red, yellow, blue or yellowish green? Red is extremely acidic. Yellow is more of towards the acidic. What else do we have? Yellowish green and blue. Blue is extremely base, so it should be yellowish green. Okay. Now, which of the following is or are true when HCl gas is passed through water? Okay, HCl gas is passed through water. It does not ionize in the solution as it is covalent. It ionizes in the solution. It gives hydrogen and hydroxyl ion in the solution. It forms hydronium ion in the solution due to the combination of hydrogen ion with water molecule. Okay, so it of course ionizes in the solution, so does not ionize is wrong. Eliminate that option with 1. Okay, 2 must be there because it does ionize in water, so it should be this. Let's just check the rest of them. It gives both hydrogen and hydroxyl ion in the solution. Basically, this hydrogen does not exist as H plus. It will combine with water to form H3O plus hydronium ion. So this is incomplete and it should be hydronium ion, right? So this is correct. So 2 and 4 are correct. Okay. Next, which of the following is true for acids? True for acids. I'm sure that in your classes you would be taught that B for bitter, B for base, so you can remember that bases are bitter. So yeah, you can eliminate these two. Here acid will turn the litmus paper of blue to red, so it should be third option. Okay. Which of the following are present in a dilute aqueous solution of HCl, hydrochloric acid? HCl, again, when it dissociates, it forms H plus and Cl minus. This H plus will combine with the water molecule to form H3O plus. So finally you will have H3O plus and Cl minus. So it should be first option. Alright, next. Okay. Identify the correct representation of reaction occurring during the chloralkali process. Chloralkali process, it's directly from the textbook. You should just remember the sequence of it. I think the reactants and products, nothing is changed, but the states are changed. So yeah, it should be fourth option. This is directly from textbook and you should be knowing this up till now. Okay. So next. Oh, we're done with the MCQ questions. The short answer questions we'll be doing in the next video. So I think this video was really, interactive enough, and definitely spread the key of success, spread knowledge. Thank you.